Dear student, today in this video lecture discuss about the TCP transmission control protocol. Now, first define what is the TCP. TCP is a connection-oriented protocol. It creates a virtual connection between two TCPs to send data in addition. So TCP use flow and error control mechanism at the transport layer. So following topic discussed in this video lecture. What is the TCP services, TCP features, segments, how connect, how establish the connection between TCP, flow control and error control. Now, first some well-known ports are used in TCP, which is described in the table. Means 7 protocol echo received datagram by sender. 9 means discard any diagram, a datagram that is received. 11 user active users that are protocol and that is port and their description are used in the TCP. So first, so the stream delivery. It means sending process in TCP send a stream of byte in form in an order and TCP receiving side receive the process. Now, so sending and receiving buffer work like that shown in the figure. First sending process. After the sending process, TCP perform following function. Next byte to write buffer and send. Next byte to send. If not sent, then process stored here. Now stream of bytes travel in transmission medium and then send received by buffer of receive process. This is the process of sending and receiving buffer. Similarly, TCP segment work here, sending process, next byte accept buffer and segments with transport header and some sequence number are travel transmission medium and receive the receiver side and receiving process similar to the sending process. So the byte of data being transferred in each connection are numbered by TCP. The numbering starts with the randomly generated number. So the value of sequence number field of sequence defined the number of the first data byte contained in the segments. So the value of acknowledgement field in a segment defines the number of the next byte. The party expects and receive the acknowledgement number is computed. Here in the diagram, show the TCP segment format. In TCP are contain header and data, 16-bit source port address and 16-bit destination port address. Now 30-bit sequence number are used in TCP segment header. 32-bit are used for acknowledgement number. Header length is 4-bit, reserve bit for 6-bit. Some control signal are used. Register are used. Window size is 16-bit, checksum is 16-bit, and urgent pointer is 16-bit. And last option and pattern. So first is control field. Explain control field. Control field is contained following frame. URG urgent pointer is valid. ACK means acknowledgement is valid. PSH request push. Reset the connection. Synchronize sequence number. Terminate the connection. That are different type of control field are used in TCP. Description of flag in the control field like that URG, ACK, ERG means the value, urgent pointer field is valid, acknowledgement, push the data, reset the connection, synchronization sequence number during the connection, and FIN means terminate the connection. So connection establishment using three-way handshake. Suppose client and server want to communicate with each other. So the first process, client send the message to the server with sequence number 800 and synchronization. Now server received, after receiving the server with the acknowledgement sequence number 15000 ACK001 synchronization plus acknowledgement. After receiving the client acknowledgement plus synchronization, send the acknowledgement and establish the connection. This is process establish connection between send client and server in 3 steps. So it is also a 3-way handshake. SCN synchronization SYN segments cannot carry data, but it consumes one sequence number. So asynchronous plus ACK segment cannot carry data, but does consume one sequence number. For data transfer like that, client first send the request. After establish the connection, client sequence number plus acknowledgement send data 800900 after and next data 9001 10,000. After receiving data, the server sent the acknowledgement sequence number 15001 data 15001 to 1700. Now next send the data from send client and DWND 1000. This is the process of data transfer between client and server. So connection termination using 3-way handshaking also are used if client server first establish the connection using the 3-way handshaking. After transferring data, the connection termination are required. The connection termination using 3-way handshake. So client and server first client active close send sequence number acknowledgement with sequence number of message FIN. After receiving the message, then send the sequence with sequence number Y acknowledgement X plus 1 FIN plus AC acknowledgement with FIN. Now client X ACKY plus 1 ACK set the termination message and release the message, drop the message carriers between client and server. So FIN segment consume one sequence number if it does not carry. Similarly, FIN plus ACK segment consumes one sequence number if it does not carry data. Half close like that. Sender send sequence number K with FIN. After receiving server, send acknowledgement with sequence number. Suppose that data segments are server to client and acknowledgement client to server. So that ACK plus synchronize send to data and receiving. After receiving that is the terminate the process. No half close. For flow control maintaining, we use the sliding window size. For window size, minimum RWND, CW, and window wall move after sending data in left direction and opening after receiving the acknowledgement. So a sliding window is used to make transmission more efficient as well as the control the flow of data so that the destination does not become overwhelmed and data TCP sliding window are by overheated. For example, what is the value of receiver window RWND for host if the receiver host B has the buffer size of 500 bytes and 100 bytes are received and unprocessed? So simple solution of this example, the value RWND 5000 minus 1000 equal to 4000. Host B can receive only 4000 bytes of data before overflowing its buffer. So host B advertises this value to the next segment. Similarly, next example, what is the size of the window for host A if the value of RWND is 3000 bytes and the value of CWND 35,000? We use minimum value of 3000 and 3500, so minimum value 300. Next example shown here, sent acknowledgement cannot send until window opens. Window size minimum 20 to 9 means 9 and can send be immediate. So next byte to be sent, showing in the yellow color, send the acknowledgement and cannot send until window opens. So some general point about TCP sliding window protocol. The size of the window is the lesser of RWND and CWND. Next general point, the source does not have a send full windows worth of data. Next point, the window can be opened or closed by the receiver but should not be shrunk. The destination can send acknowledgement at any time as long as it does not result in a shrinking window. The receiver can temporarily shut down the window. The sender, however, can be always send segment of 1 byte after the window is shut down. This is the some point about the transmission control sliding window. And several times we define if ACK segment do not consume sequence number are not acknowledged. In modern implementation, a retransmission occurs if the retransmission timer expires or 3 duplicates ACK segments have arrived. No retransmission timer is set for an ACK segments. Data may arrive out of order and the temporary stored by the receiving TCP, but TCP guarantees that no out of order segment is delivered to the process. So normal operation. So in the figure, sequence 12012 1400 acknowledgement 4001, sequence number 400 to 500 and acknowledgement 4001. After a 500 millisecond, acknowledgement 500 sent, and this is process normal operation of between client and server. Suppose that last segment during the transmission data between sender and receiver. Suppose the sender sent the sequence number 5012600 ACKX, received the buffer by receiver and sent the acknowledgement. Send the acknowledgement 70. Suppose that sequence number 701800 ACKS lost. Now next message sent by sequence 8090 SCN or receive acknowledgement 701. Now here is gap or receive the buffer out of order, then resend after some time interval. Center resets the sequence number 70800. After receiving, the signal is received in form of order. So here receiver TCP delivery only ordered data to the process. So fast retransmission like that, sequence are sent by sender this acknowledgement, receive the buffer, send the acknowledgement, next 20130, receive the buffer and send the acknowledgement. If this is lost, but next sequence received only that last signal, only that last SN300 gap is created, next acknowledgement received, next, and at the end the acknowledgement last signal is sent by the sender and received all in order form. So this is the total TCP protocol in transport layer and their connection management, three-way handshaking, connection termination, three-way handshaking, and their simple operation. So in this lecture, thank you.